Welcome back to Maths Playground. Today we'll be doing 5 problems of telescoping. Just in case you don't know what telescoping is, I'm going to explain it right now. So you know how a telescope makes further things look bigger and closer? Telescoping is similar, but um it's to add long series of numbers and find patterns that you can write with one symbol and the pattern. I'm going to show you with our first problem. We have 2 basic problems and 3 challenge ones. Okay, our first problem. Evaluate 15 minus 14 plus 14 minus 13 plus 13 minus 12 plus 12 minus 11 plus 11 minus 10. Okay, now if we find a pattern, in general, we have n. Let's say that our common number is n, so n minus n minus 1, right? Because the greatest value here is 15, and our lowest value is 11. So to add, we have a symbol called sigma. It looks like this, and this means sum. So if we wanted to write this whole thing in sigma notation, it would look like sigma of our pattern, which we notice is n minus n minus 1. But for the values of n, like if it showed up in a test, how would you know what the greatest value of n is or the least value of n? Our least value of n goes on the bottom. So our lowest value here is 11. The greatest value is 15, which goes at the top, but we don't have to write n is equal to 15. Well, unless you want to. If you don't, it would take some time. So, if this is equal to this thing, I'm just gonna write this down, 15 minus 14. Remember, sigma is equal to sum, so we have to add. So it's 14 minus 13 plus 13 minus 12 plus 12 minus 11 plus last one, 11 minus 10. Okay, so there's a negative 14 here and there's a positive 14. There's a negative 13, a positive 13. So we can like cross these out and we're left with 15 minus 10, which is equal to 5. Notice how telescoping is sort of a survival game. Which numbers survive and which numbers don't? This is why math is so fun. Okay. Our second and last basic problem. Evaluate sigma of k sigma 1 by k minus 1 by k plus 1. Least value of k is 1 and greatest value of k is 12. So this here, k is equal to 1, 12. So this would be so this would be 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus by 4 plus 1 by 4 minus by 5 plus 1 by 5 minus 1 by 6 plus 1 by 6 minus 1 by 7 plus 1 by 7 minus 1 by 8 plus 1 by 8 minus 1 by 9. My God, my arm hurts already. 1 by 9 minus by 10 plus 1 by 10 minus 1 by 11 plus 1 by 11 minus 1 by 12 plus the last one, finally, 1 by 12 minus 1 by 13. Okay, so we're negative 1 by 2, positive 1 by 2, so on and so forth. This is a pretty long survival game. Sorry, that, and that. And we're left with 1 minus 1 by 13, which is equal to 12 by 13. Okay, now for the challenge problems. Challenge problems, survival game. Here we come. Okay. Challenge problem number 1. Evaluate sigma of 1 by k times k plus 1. Least value of k is 1 and greatest value of k is 10. Okay, so let's see how this works. So 1 by k times k plus 1 is also equal to 1 by k minus 1 by k plus 1. So we can write this thing over here as sigma k is equal to 1 10 of 1 by k minus 1 by k plus 1. So that would be 1 by 1 minus 1 by 2 plus 1 by 2 plus 1, minus 1 by 3 plus 1 by 3 minus 1 by 4 plus 1 by 4 minus 1 by 5 plus 1 by 5 minus 1 by 6. What do we have? Plus 1 by 6 minus 1 by 7 plus 7 minus 1 by 8. Oh my God, I'm about to break my wrist. 1 by 8 minus 1 by 9 plus 1 by 9 minus 1 by 10 plus 1 plus 1 by 10 minus 1 by 11. Okay, so that's that. 1 by 2, 1 by 2, 1 by 3, 1 by 4, 1 by 4, 1 by 5, 1 by 4. It's all going to cross out until we get to 1 by 11, which is not too far. And we're left with 1 by 1 minus 1 by 11, which is equal to 10 by 11. That wasn't too challenging. Well, hopefully it's going to get more, because I am so excited. Okay. Challenge problem number 2. Evaluate sigma of 1 by k times k plus 2. And the least value of k is 1, and the greatest value of k is 8. Okay, so now we obviously don't want to keep multiplying for every single value of k. So if we try doing 1 by k minus 1 by k plus 2, we'd get k plus 2 divided by k times k plus 2 minus k divided by k times k plus 2. Okay, so this would be 2 by k times k plus 2, which is not what we want, but we want half of this. So we can also write this as sigma of k, sigma of half of 1 by k minus by k plus 2, which is equal to we can take half out common because that's what we're multiplying all of them with. So then we have 1 by 1 by so we have half of this, so k is equal to 1, so 1 by 1 minus 1 by 3 plus our next value is 1 by 2 minus 1 by 4 plus 1 by 3 minus 1 by 5 plus 1 by, so this was for 1, 2, so 1 by 4 minus by 6 plus 1 by 5 minus 1 by 7 plus 1 by 6 minus 1 by 8. We're nearly there. Plus 1 by 7 minus 1 by 9. Plus last one, 1 by 8 minus 1 by 10. Okay, so let's see how many of these guys survive. So we have negative 1/3 and positive 1/3. We have negative 1/4, positive of negative of 10. That we can cross these out. This one negative versus the positive there. Anything else? Nope, doesn't look like it. So we have half of 1 plus 1 by 2 minus 1 by 9 minus 1 by 10. So now this would be half of this would be 90 plus 45 minus 90 plus 45 minus 10 minus 9, which is equal to half times 116 divided by 90, which is equal to this. So which is equal to 58 by 19, and you can simplify this, 29 by 45. So that's your answer. Not too challenging. Last one, and we're done for today. Okay, and last problem. So, evaluate sigma of 1 by 2k minus 1 times 2k plus 1. The least value of k is 1 and the greatest value of k is 9. Okay, so we obviously don't want to go over multiplying this all the way from 1 to 9. So let's see how else we can write it. So if we try writing this as 1 by 2k minus 1 minus 1 by 2k plus 1. Let's solve this just to make sure. So 2k plus 1 divided by 2k minus 1 times 2k plus 1 minus 2k minus 1 divided by 2k minus 1 times 2k plus 1, which is equal to 2 by 2k plus 1 times 2k minus 1, which isn't what we wanted, but we can write as half of this thing, right? So sigma 1, 9, let's see, we can make this as half of 1 by 2k minus 1 minus 1 by 2k plus 1. So like the last one, we can take half out common times, my first one would be 1 by 1 minus 1 by 3. 1 by 1 minus 1 by 3 plus 1 by 3 minus 1 by 5 plus 1 by 5 minus 1 by 7 plus 1 by 7 minus 1 by 9 plus 1 by 9 minus 1 by 11 plus 1 by 11 plus minus 1 by 13 plus 1 by 13 minus 1 by 15 plus let's see how many we've done. So 1, 2, 3, 4, 5, 6, 7. Okay, 1 by 15 minus 1 by 17. Then our last one, which is 1 by 17 minus 1 by 19. Okay, which is equal to, first let's see which one survived. 1 by 3, 1 by 3, 1 by 5, and 1 by 5, 1 by 7, 1 by 10, 1 by 9, 1 by 9, 1 by 11, 1 by 11, 1 by 13, 1 by 15, which is equal to half of 1 minus 1 by 19, which is equal to 1 by 2 times 18 by 19, which is equal to 9 by 19. And that's your last problem for today. See you next time, mathematicians.